Hello everyone, welcome back to my channel. Today we are going to be talking about the modified binary search pattern. The last time we discussed the binary search pattern and we mentioned that there has to be a precondition to be able to apply the binary search pattern, which is the fact that the elements have to be in a particular order. This order can be either ascending or descending. For example, in the case of finding the integers within finding a particular integer within an array. So what makes the modified binary search pattern different? So I'll just have this just by the side, modified binary search. So looking at the description, modified binary search, it simply means that we are going to apply a binary search pattern. However, we just need to modify it or extend it a little bit to be able to search for an element in a particular kind of array. So here is how it works. In the initial case, remember that we had these elements in this array as 1 all the way to 21 in an increasing order. In this case, for the modified binary search pattern, what happens is we are given an array that is also in the particular order. However, the elements in this array are, if you imagine, kind of shifted. So what that means is that imagine that let me actually just take a copy of this. Let me take a copy of this so that I can move it across. No, that's not good. Let's take a copy of this. Okay, yeah, this is okay. So in this case, for the modified binary search pattern, here is what happens. We have, this is the initial array where we performed binary search on. However, if you imagine that this array now, it transforms into something like this, whereby imagine that we move this one across all the way to this point. So that way, then the array becomes 3, 6, 9, 11, 14, 21, and 1. This is the new array. We've shifted the 1 away from where it was all the way here. Then let's say we do the same thing for 3. We shift the 3 across also over also. So the 3 comes all over here. Let's say we shift this 6 also. 6 comes all over here. Now at the end of the day, we have is basically is the same array, just that there's a transformation of the array. We've moved all this some of the elements on the left portion all the way to the right. Question now is, how do we search for the same element, let's say 14, in this input array? Or how do we search for the index position of 1 in this array? We can use the same binary search pattern, just that we need to modify it in a particular way. The reason is because the elements in this array, they still maintain an order. And this time around, the order is sort of like an increasing order, and then at some point there's sort of like a break, and then the increasing order continues. You see, so 9 all the way to 21, then the sharp break, and then 1 all the way to 6. We can see apply binary search on the pattern. So imagine that we can apply binary search on this portion or on this portion. The same algorithm that we've done initially. And the reason why we can do that is, remember, I said earlier with the example of a couple of truths, then a couple of false. There's some form of order maintained here. And as long as there's a form of order, we can apply binary search. But in this case now, we need to modify our application of binary search. That is where the modified binary search comes in. So how do we do it? So I'll just be making a comparison between this and the binary search pattern so that it makes more sense. So when it came to the binary search pattern, remember what we did? We divided. Yeah, we go to the middle of that of the initial array, and then we determine what is the element in that position. Then we ask the question: is the element in that position less than the element at the element we are looking for? If it is less, that means that we can really discard the left portion and then search on the right. Yeah, that was what we did. And we repeated that process all over and over. Yeah, but the core point of all of that is that we go to the middle. Then after going to the middle, we now determine if we should search the right or left. This is actually basically what we did. So we go to the middle, then we determine should we search the left or should we search the right. The way we determine if we should search the right or left in the initial binary search pattern is to ask the question if the element at that middle position is less than what we are looking for or greater. Yeah, or equal. If it's equal, we just return, say that we found. Yeah. But in the case of this now, actually, you know what? I think I need to have this side by side because this is also this is also applicable to this is applicable to both of them. So let's just do this. So to perform a search now, to find, say for example, now, I mean, we've been asked to find the element 3 and its index within this input array. We're going to perform this same operation. We're going to go to the middle and we're going to determine if we should search on the right or we should search on the left. This is where the modification comes up. Here, determining whether we need to go left or right. That's what makes it modified binary search. So how do we do that? We do the same thing. We go to the middle. The middle here now is this 21. At this middle position, we then ask ourselves the question, should we search the left portion of this array or should we search the right portion of this array? How do we determine if we need to search the left or we need to search the right? Here's the thing. We are looking for the number 3. In that number 3, we need to ask ourselves the question, is that number 3 less than this element in this array? Or is it greater than the elements in this array? So if you think about it, number 3, if for example, this number we are looking for, number 3, is greater than the elements, assuming that the element you asked us to find is 24. 24 is greater than 21. So that immediately tells us that we cannot search the left because we know that the elements in this array are increasing from left to right. So definitely we cannot search the left, we should search the right. So we discard the elements here on this right half. And then we search on the right for this element 24. Do you see? But in this case now, we are looking for the element 3. Now, because the element 3 is less than the element 21, ideally, what we will have done in regular binary search is to just go to the left and search for the elements in this position. But this time around, because these elements have shifted, we cannot entirely see if the number we are looking for 3 is on the left half or is on the right half. We cannot see. We don't know. So, how do we determine if we need to search the left half or the right half? Yeah. So what we need to do is we need to come to the rightmost end of this array. It's the rightmost end. And then we now need to check the element in the rightmost end. We can easily, in constant time, we can find the rightmost end of the array. We check if the element in this position, we compare it to the element we are looking for. So the element you're looking for is 3. And then we compare that with the element at the rightmost end of the array. If the element we are looking for is less than the element in the rightmost end, we definitely know that we should be searching for what we are looking for from that position all the way to the mid that we had initially find. So we should search on the right side. However, if the element you're looking for is larger than the element in the rightmost half, and the element in the rightmost position of the array, that immediately tells us that, okay, we should continue our search on this end of the array. And then repeat the same process over and over again. So remember, the same idea. Go to the middle, then determine if we should search on the right or we should search on the left. If we were to be a regular binary search pattern, you just ask, is the element in the middle less than or greater than the element you're looking for? That is enough for you to determine if you're going left or right. But in this case, where the elements in the array have shifted a little bit, there has to just be a little extra trick or an extra step to your definition of whether you need to go left or right. In this case now, aside from just checking the element at that position, you need to also check the element in your rightmost half. Actually, you can also do it by checking the element in the leftmost half. Yeah, but this is sort of like the most straightforward way to think about it. Yeah, so then in this case now, we immediately discard all of this, and then we now search within this smaller array 1, 3, and 6. And now, definitely at this point, when we immediately go to the middle of this array, figure out that the element you're looking for is 3. But assuming that the element you're looking for is not 3, say that the element you're looking for is 1. Yeah, in this case, we will land at the middle. And then once we land at the middle, when we need to ask ourselves the same question, the element you're looking for is, let's say, hey, we are looking for the element 1. Now remember what we asked ourselves initially. We said the element we are looking for, is it less than or greater than? Yeah, so if the elements we are looking for is greater than the mid, what do we say? We say we should go right. Yeah, that makes sense. The element you're looking for is greater than 3, then I mean we should go right. In this case, we're going right because this is the array. This is what we regularly do. Well, when the element you are looking for is lesser, in that case, we should go left if in a regular binary search pattern. The only difference now is that in this case, because the array could have been shifted, we need to now ask ourselves the question: what is the element at the rightmost end? If you just take a minute to think about it, you can always come up with a solution to this. Just remember the core concepts. Go to the middle and then determine if you need to go left or right. And determining if you need to go left or right, that is where it becomes a little bit tricky. Yeah, we just take a minute to think about it on that position, at that point where you are, then see, okay, based off of what I have in this input, should I check left or should I check right? And what you need to do actually is check the extremes. Look at the extremes and then use that to determine if you need to continue to search on the left or continue to search on the right. So this way, at the same time, you are splitting the entire array into halves and then repeating your search over and over. So this is the modified binary search pattern. And it's another really important pattern that you should have in your arsenal. Also going to help you being able to address some algorithmic problems. So I would also try to share some questions regarding this in the description. Please take some time to practice this. Hopefully, I'm planning to one day just come up and try to attempt all of these problems. Yeah, but it's also important that you guys try to solve them personally. Okay, so please don't forget to like, share, and subscribe, and continue to come back here to enjoy this algorithmic patterns that we're discussing. All right, guys. See you guys in another session where we'll be discussing the next pattern on this list, which is the DFS pattern. DFS stands for depth first search. All right, guys. Bye.